Hello, everyone, and welcome to another lecture for Auto 105, Automotive Manual Drivelines. Today, we're going to talk about Chapter 5, which is drive shafts and half shafts. Half shafts is another term for an axle shaft. Now, what these items are is these are our links between our powertrain components. So, in most cases, the transmission has the drive shaft as an output and going down to a differential and then out to each axle shaft. In the case of a four-wheel drive vehicle, we're going to have the transfer case have the two outputs, one for the front axle and one for the back axle, and it be connected directly to the transmission. There are some cases where you can have a divorce transfer case where you will have a small stub shaft, but that is very rare and typically on older vehicles. Our drive shafts come in a bunch of different designs, and that's going to be based off of the chassis layout and how the vehicle is being used. They can be made from aluminum, steel, carbon fiber, and they have to have the ability to change angle. Even on vehicles that the drive shaft is fixed because the transmission and engine are fixed and the differential is fixed because it's got independent suspension, you still have to have some form of flex in between the two. For the most part, what we're going to have is we're going to have a universal joint. A universal joint is a cross-shaped device that allows for the increase in velocity at every 90 degrees of its rotation. They also can operate at a specific angle. We can double them up to create a double cardian joint if that's the case. Now, we're looking at not all manufacturers will use the exact same design, but for the most part, U joints are pretty universal in their name. And we see them across a lot of different makes and models. However, when you start to look at some European vehicles and some early Japanese vehicles, they were using a constant velocity joint, which we will see when we talk about axle shafts. But our universal joint, otherwise known as a hooks joint, although I've never heard anyone bring that up whatsoever, but a U joint is a cross section. Doesn't look like a U whatsoever. It's called a U joint because of the term universal. They will have a specific diameter and cap rating, and they can be rated for different torques, but they will be located on either end of a drive shaft. And again, in some cases, we can have a double cardian joint on one end, typically the end that's coming out of the transmission or the transfer case, and it will have two U joints plus a spherical joint in the middle, so that we can have a greater operating angle. But those universal joints will be located inside of a yoke or a flange. The drive shaft that's photoed there on the right of the screen is a front and drive shaft for a four-wheel drive vehicle, and instead of a yoke that slips, we have a drive shaft that slips, and we have mounting flanges. That's a pretty atypical for modern vehicles now. And the reason why they do that is we eliminate the slip yoke, and it's one less area of wear. As the universal joint rotates along its plane, it's going to speed up and decrease. And again, at an every 90-degree interval, it's going to be doing that. Uh, when we have two U joints counteracting that strange vibration, we can operate a drive shaft at multiple angles because they will be able to pivot off of the Torrington bearings inside of each cap. And allow for a cancellation of harmonics. Now, the little tiny bearings that are inside of the cap of the universal joint allow for it to spin on the universal joint's pinion, which is typically cast into the frame of it or the cross of the joint itself, and it allows for free spinning. That's going to be the component that wears out, is that bearing, that Torrington bearing or those rollers against the actual U joint itself, and that's atypical where they fail. However, you can have to where you can have a catastrophic failure of the joint coming apart or the straps coming apart that hold the joint caps in place. These joints do require regular maintenance and lubrication. More modern vehicles now, a lot of things are serviced for life, but universal joints are one of the very last things that can be greasable. You can get a 2024 vehicle that does have a Zerk fitting for greasing the U joints. Now, when I brought up that change in velocity when we look at rotating every 90 degrees or so, we have an area of stall and an area of acceleration. And again, you can see that at the 90 degrees, 180 degrees, 270, and so on and so forth, 360 degrees. That will allow for that speed change. And again, it's going to be canceled out by the opposite joint on the other end. So there's no harmonics. But that does mean that if there is an issue with the universal joint to where we can get it out of phase or one of the joints is worn out and it's able to rotate a little bit slower and cause a little bit more drag on the drive line, we're going to have reduced performance and you will have a vibration that can correspond with that. Now, maintenance to a U joint, other than servicing it, again, is pretty simple. Locate the grease fitting if it has one. Usually, it's going to be in the body of the universal joint itself. And that grease fitting is going to go through a series of channels that will send grease to all four corners of the cap of the universal joint. You wipe off any dirt so that you don't put any contaminants in. You then apply the correct grease. It is important, and this is why a lot of manufacturers do not have people grease components anymore to get the right grease. Now, the bottle of that says multi-purpose, but we do want to make sure we're getting the right GLA rating grease for our universal joints. The other thing that you want to look at in terms of, what kind of component you're looking at is do have an understanding that if you overgrease the U joint, you'll pop the seals out and you can do more damage than good because you'll lose all of the grease. So less is more. Usually you're doing 1 to 2 pumps. You will attach the quick release fitting for the grease gun to the Zerk fitting, and then you will apply a small amount of grease. I don't like it when you start to get the grease to pop out, like it's stating here in the PowerPoint and what it states in the book. Usually, what instead I want to see is I want to see that seal begin to move. And what I mean by that is when we look at the U joint itself, there is a seal located right here that the grease is popping around. You will see that go outward when it starts to fill with grease, and that's when you stop. And again, usually we're looking at maybe 1 to 2 pumps of the grease gun or full cycles of the trigger of the grease gun. You can get into trouble. They do make cordless grease guns that are electric. Those are meant for heavy equipment that you have to like grease hydraulic ram that's going to take a whole lot. So when you hit the trigger, you got to be really, really light on those. So personally, my grease gun that I used a manual one only because I'm doing suspension or U-joint components that don't need that much grease. After that, wipe away any excess grease from the caps or from the Zerk fitting, and away you go. And that's all the maintenance that you have. Now, I'd broaden up that not all vehicles are going to have universal joints. In some cases, they can have a constant velocity joint, and that's what we're starting to see in most vehicles. But there are some vehicles that will have the transmission and engine fairly fixed. When I say fixed, they are on mounts. It's going to flex around a little bit, but it's fixed in the sense that it's not moving or the drive shaft isn't going to be changing angles. Thus, the differential, if it is independent suspension, front or rear, will also be fixed. So we do not have to have that great angle difference. What we will have in place is a flex disc. Now, this is used and on a lot of vehicles with fixed powertrain components, and it allows for reduced noise. It allows for a little bit of expansion due to heat from either component, and it does allow for a small amount of give, and that will make less of a harsh engagement, and it will ultimately kind of pay off in dividends in the vehicle having less NVH or noise, harshness, and vibration. Now, these discs are going to be made of a very dense rubber composite, and they will usually have where the fasteners bolt up to them. They will have a anti-crush collar, so that you don't completely smash the rubber themselves. And they tend to be on a 3-on-3 style bolt pattern, 3 on the drive shaft and 3 on the output flange. And that usually will be bolted either to a traditional steel drive shaft or a aluminum tube drive shaft. It really kind of depends on the manufacturer. When it comes to construction of a drive shaft, the metal being picked does matter. Now, the benefit to having an aluminum or a carbon fiber one, for instance, is obviously the weight savings. Downside, though, is an aluminum drive shaft does have to be bigger because it is a more brittle material. It also is not as strong in terms of impact damage and can be a lot easily or a lot more prone to damage. But the advantage in reduced weight and reduced drivetrain loss or frictional loss mitigates the issues that it can have. Oftentimes, if you have a four-wheel drive vehicle, you will have a steel drive shaft, and steel drive shaft is pretty common. You can see that in the photo above, and it's clearly steel because it's rusting, which is again another fun thing with drive shafts. Is from the factory they tend to not coat them for some reason. Uh, it is not a bad idea to paint them so that they don't get all rusty and crusty. The aluminum drive shaft too, they will have to have noise mitigation installed in them. Oftentimes it's kind of just rolled up cardboard, but it still allows for a reduction in the echoiness that you can have in a drive shaft. I have had situations where there was a noise and it was transferred through the drive shaft, and it was a noise actually from the pinion bearings in the differential. So there was an issue in the rear diff that the drive shaft output flange was directly bolted to, and that transferred the noise forward to where it did sound like the noise from the occupant area or the passenger area from the driver or the front passenger, that the noise was actually the transmission. When you got out of the vehicle and you used a set of Steelman ears or the little microphones to kind of pinpoint where the noise was coming from, you were able to tell that yeah, clearly it actually did come from the differential and the noise was transferring or being trumpeted through the drive shaft itself. Now, the last material the drive shafts are typically made out of is carbon fiber. Carbon fiber is very light, but also very strong. It's equivalent to steel. Carbon fiber drive shafts you'll see on performance vehicles. The tube itself will be made of carbon fiber, but the actual joints usually are going to be made of billet or cast aluminum. You can see carbon fiber drive shafts as factory drive shafts on OEM vehicles. The downside to carbon fiber, though, is it is very prone to damage or to catastrophic failure if there's a nick. So if there's any kind of ding in the drive shaft at all, it can break and shatter. We tend to see these types of drive shafts protected by under trays. In a lot of cases, whether or not it's a steel drive shaft, aluminum drive shaft, or a carbon fiber drive shaft, it will be a single piece design, meaning that you'll have a output flange, a U joint, or a rubber disc, or a constant velocity joint going down through the tube to another flange and joint of the same design. However, we can't exceed a certain length on drive shafts, and I'm actually pushing my luck with my personal truck. It is a standard cab short bed, and it is using about as long as a drive shaft as you can. I'm about an inch under, excuse me, from what most manufacturers will deem as okay. You don't really want to go above 68 inches in drive shaft length. When that is the case, what you do is then you have a separated drive shaft. You can have it in multiple pieces. I had the unlucky role of working on a lot of limousines when they came into the dealership, and the limousine effectively is just a car cut in half and then a 14-foot section added to the middle of it. Well, you have to add space and length to other components that are in that 14 foot. So brake lines, fuel lines, electrical, and the drive shaft. And quite often the drive shaft were in multiple pieces. Most of the time for a 300C limo, which is what we only had limos come in as, it was usually a 5 or 6 piece drive shaft, meaning there was 5 or 6 sections. We also have this too with our larger trucks, so our 4500s and 5500 pickup trucks can come in fairly long wheelbases, and in that case, you can have up to 3 or 4 piece drive shafts, and that's not uncommon. In between each drive shaft, you will have an additional U joint. So a 3 piece drive shaft, for instance, will have 3 U joints. But the key thing is because you have 2 shafts, you will have a center support bearing. A lot of Toyota pickup trucks have that center support bearing, and it is an area of failure. That's not, like when I say failure, like it's not, the drive shaft's not going to go through the floor or anything, but it is going to be something that can make some noise, and it does need to be looked at when you're diagnosing a vehicle for a drivability noise. Now, what's pictured there on the left of the screen is one of those carrier bearings, and it effectively is just going to be a roller ball bearing in a rubber isolated case that will have a steel outer shell over it, and it's usually bolted up with two bolts. They are an area of wear. Now, it's not going to affect the angle. It is just there to support one of the two shafts. Anytime you have multiple shafts, you do have to have one of the shafts supported at both ends for the joints to work. Now, the advantage to having a two-piece drive shaft is you do have the ability to have a longer wheelbase, but you can also change the angle. So if you have an offset diff, or if you have a lifted vehicle or a vehicle that rides higher than an otherwise normal vehicle, you can have that increased angle because you have multiple joints instead of just the two single joints. Because you really can't exceed about 3.5 degrees of constant use or constant operation of these U joints. However, they can go much further than that. When we have a live axle or solid axle design suspension in the rear with a differential that's going to move up and down as the suspension moves up and down, we have to have the ability for the drive shaft to be able to collapse on itself. And there's a couple different ways that we can do that. One way is with a slip yoke, and that's what's photoed there. And a slip yoke is a section of the drive shaft, usually around 4 to 7 inches, that is going to be internally splined into the transmission and sealed against a dynamic output seal. And as the suspension goes up and down, the drive shaft will move in and of the out of the back of the transmission and allow for the drive shaft to stay in connection with the rear diff. When we start to lift vehicles a little bit too high, or we start to operate the drive shaft at a more aggressive angle, these can slide out. So it is a very common modification, or it used to be when Jeeps had slip yokes on their rear drive shaft, that you would do what's called a slip yoke eliminator kit inside of the transfer case. That's where you take the transfer case apart, and instead of having the slip yoke, you eliminate that and you put an output flange. And then at that point, your drive shaft is going to have a collapsible center section. That collapsible center section will allow for the movement of that live axle, but it won't slip out or fall out if you overextend past the slip joint as it would normally. So the slip joint on most of these drive shafts is greasable and is serviceable, and you apply a little bit of grease to it, and it allows for longer life of that joint. We tend to see these a lot on front drive shafts, but they are on rear drive shafts now because of most customers are not going to want to have to think about that if they are venturing off road. One of the things I do want to note in this photo, though, is that when you take a drive shaft out of a vehicle, there's a couple considerations you need to take. The first is if it is a slip yoke drive shaft, when you take that drive shaft out of the back of the transmission and or transfer case, whichever it happens to be, it will leak fluid out. So you do need to have a method of catching the fluid or a method of sealing it up. I personally have taken apart old drive shafts from vehicles that I've replaced them on, and I take the slip yoke out and I will have just a dummy slip yoke that I can slide into the back of a transmission if I'm removing the transmission or if the drive shaft's out for any other reason. The other thing that you want to do is if you do not have a captured U joint, meaning that it is fixed into two yokes and the only one end is fixed, you will want to make sure that you secure the end caps, and that's what's going on right here. So you can see a small amount of black tape going around the joints to hold those caps in place. Why you want to do that is there is no method to keeping those untethered caps in place other than that electrical tape. And if they fall on the ground, it tends to fall, hit the ground, and then all the needle bearings come out. And that obviously is going to ruin the joint because you won't be able to probably find all of those little tiny rollers. So applying some tape around it, masking tape, duct tape, electrical tape, it doesn't matter. Personally, I find the less sticky your tape, the better. So electrical tape or masking tape, and you just roll it around and have the tape hold tension, usually is the best method to hold the drive shaft caps in place when you have everything apart and on the bench. Now, those compression style drive shafts will have a output flange or companion flange on the diff, the transfer case, and the transmission. If that's the case, and we will bolt the back of the drive shaft or the front of the drive shaft if you're going to the trans or transfer case end to that companion flange. It's really important when you do remove it to get it in the exact same position as it was or phase it in the same position as the drive shaft came out. That way, you're less likely to have a vibration. You can see the photo there on the top of the right of the screen. You can see a very clear outline of the output flange as it goes into the differential there. So you kind of, as long as you can line it up, but it can be 180 degrees out. It's not a bad idea to mark it with a little bit of tire chalk or like white pen or like a paint pen. The other thing that you can see, especially on a lot of modern vehicles, what's photoed there on the bottom, and it will be a harmonic dampener that is part of one of the U joints. Why we have these harmonic dampeners is anytime you have something that's spinning, there will be an inherent out of balance and thus a noise or vibration that can be felt. So a lot of manufacturers are installing these harmonic dampeners to cancel out a noise that the drive shaft might make or a harmonic that the drive shaft might turn under that can otherwise annoy the operator of the vehicle. These are usually serviced on, the drive shaft as a whole. They're not removable at all. They're pressed in. One thing I will note with these is in more saltier climates where they salt the road for snow. These do tend to get eaten up. The rubber gets worn out, and then the cast iron pieces, it's what it's usually constructed of, come apart, and they can make a fair amount of noise. And you do have to usually replace the drive shaft when those fail. There are a couple vehicles out there, like what I have photoed here with a Corvette, that have a torque tube. Now, a torque tube is going to be a transmission that is not attached to the back of the engine. Instead, what we'll have is we will have a output of the engine off of the crankshaft going down a fixed tube or housing with a shaft internally to it. So Corvette has it starting with the C5 variants where they are transaxle. They've moved the transmission to the back and they still have the engine up front. You will have a torque tube. Everyone's favorite Plymouth Prowler also has a torque tube. That car is a parts car to the nth degree. The engine is from a 300M, 3.5 liter single rotor cam V6, and the transmission is from a Turbo PT Cruiser and is located out back and is a traditional transaxle if it was front wheel drive. To connect the two, there is a torque tube as the input to the transaxle. But early Ford vehicles, all the way up into the late 40s, had torque tubes as well, where the back output of the transmission went straight to the diff. And that was very common for back in the day, and with some vehicles that are front engine or rear wheel transmissioned or rear transaxle. When we look at diagnosing concerns with the drive shaft, the primary thing that you're going to be diagnosing a drive shaft for is either going to be a noise or a vibration. If the drive shaft breaks, pretty easy to diagnose. You go, yep, it's broken. I have had a bunch of drive shafts break, and it's very obvious. There's not a lot of diagnosing that needs to go on. You just kind of gotta, yeah, the car doesn't move, and oh yeah, look, the drive shaft's hitting the gas tank now, which does happen. If a drive shaft does break, you do need to stop the vehicle. It is very dangerous for that drive shaft to fling around. I have had situations where the center bearing had failed. It broke bolts. And it beat the crap out of the gas tank and the exhaust filters, and it happened to be a diesel, so the exhaust filters are, several $1,000s. The other thing that you're looking at noise-wise is there's a couple things. You can have a very heavy clunk, and that's usually going to be from a fully failed Torrington bearing inside of the joint, or you can have squeaks, and the squeak is usually due to a lack of lubrication and tends to happen at slower speeds. When I say slower speeds, like less than 15 miles per hour. Once you start to go above 15 miles per hour, the actual velocity of the drive shaft usually cancels out that noise. The other thing that you want to make sure that you are very aware of is anytime you lift a vehicle, you do have to compensate for the drive shaft. The drive shaft now is going to have to operate at a greater angle, and sometimes further away from its normal position. Thus, you have to do the modifications. I already brought up the slip yoke eliminator. But it's also something that if you start to go above 4 to 4.5 inches of lift, you will have to degree the T case or reduce the angle of the drive shaft. You can do this by having a multi-piece drive shaft, adding a double cardian joint to one end, or you get a special bracket that goes in between the transfer case and the back of the transmission that rotates the transfer case down a little bit lower so that you have less of an aggressive angle on the drive shaft. I did have a customer that they lifted a Ram truck. This was back in like 2007, that they had a 3500 Ram truck that had a 14-inch lift on it, and 44-inch tires. It was a really, really big truck, and they did not compensate for that lift with the driveline angle, and the front drive shaft ended up coming apart. Now, depending on where it comes apart, it's either going to be spinning with the engine or it's going to be spinning with the axles. And that will do the most damage. What happened on this particular vehicle is it broke at the cardian joint end, and it was still spinning as the vehicle was starting to reduce speed. Well, what it did was that giant drive shaft, and it was a steel drive shaft, went through the floor of the truck and actually ended up injuring the driver's foot pretty badly, as it came apart. And it did a number on the truck. It took a big old swash out of the floor, and the body shop had to end up putting a new floor pan in the truck itself, as well as the medical attention to the owner. A lot of racing sanctioning bodies require the drive shaft to be contained. I have welded in a drive shaft hoop on my personal truck, my old 64 Ford, when I was doing all the frame modifications, and that is a very, very common safety requirement. Now, the vibrations felt in the drive shaft, they won't be all the time, or when I say all the time, they won't be consistent in that it's going to be, you start to drive and it's already vibrating. Usually the vibration comes in at a particular harmonic. That harmonic can be speed based, either on the engine RPM or the output RPM from the transmission or transfer case, or it can be road speed related. Usually, I've found that it is going to be a road speed related vibration, and you tend to feel it in the chassis of the vehicle or in the seat. You won't feel it in the steering wheel or the pedals, and that's a usually good indication that the drive shaft is causing an issue. If you have a four-wheel drive vehicle and you're suspect that it might be the front drive shaft, you can remove the front drive shaft and test drive the vehicle to rule out if it is the cause of the vibration or not. Because you can have a four-wheel drive vehicle that is selected into two-wheel drive have a vibration due to a failed front drive shaft, and eliminating it makes it a little bit easier. I do not advise, if you do have that same four-wheel drive vehicle, to put it in four low and remove the rear drive shaft and just operate off the front. Usually that doesn't work out super great, but you can use a modern Picoscope 7 to be able to run the NVH function to be able to determine if a drive shaft is bad. Uh, Now, if a drive shaft does have a vibration, the main fail point is probably going to be the U joints, which are serviceable. You can service them. They do need to be pressed in and out. But if the shaft is out of balance or out of phase, it does need to be specially balanced. Conveniently, there are drive shaft shops still around. There is a fantastic drive shaft shop in Mission Viejo called Drivelines Unlimited. I've had them build me multiple drive shafts for multiple project cars, and they are always spot on. And I highly recommend them. They have a pretty quick turnaround on getting their drive shafts in and out for you. Tools to be able to find issues with the drive shaft: an angle finder, dial indicator are going to be your first ones. And as I brought up, an NVH tester, the Pico 7, does have the ability to calculate, using a four-channel scope on what a vibration could be in the vehicle. If you notice any outward damage to the drive shaft, that will need to be replaced immediately. If there's any nicks or bends or dents, that can indicate an issue. But you might not always be able to see it, which is why you're going to want to use a dial indicator. Usually, good rule of thumb is you do not want more than 40 thousandths um, out of round or run out for a drive shaft. Obviously, the longer the drive shaft is, the less you want because the more exaggerated that it gets. So you do want to be checking that, especially if there's a collision. What can happen is if a vehicle's in a bad enough crash and the suspension moves, quite often the drive shaft gets shoved, and that can do damage to the back of the transmission, or it can bend slightly. So it's not a bad idea to, if the vehicle does get into a collision or has a really bad jolt, to double check it. It's not very hard. You fix the dial indicator a stationary position, usually on the back of the diff or the back of the transmission, and then you run the dial and you zero it out. You just do a couple rotations to see how far out it is. Now, anytime we are talking about the drive shaft, I did bring up making sure that it's phased correctly. The phasing is important when we are manufacturing or we're fixing like a yoke end of a drive shaft, and they do have to be opposite of themselves, or you can get a pretty bad vibration if that is the case. It is always a good idea too to check driveline angle. Even if a vehicle is stock and it hasn't been lowered or it hasn't been lifted, the driveline angle can be affected, particularly by sagging motor mounts. A lot of modern vehicles now, the motor mounts are hydraulic filled, meaning that it is a rubber outside case with a liquid filled membrane. And as they wear out, they actually collapse and they lose height. What that effectively does is that lowers the engine and transmission in the chassis of the vehicle, and it can change the operating angle of a drive shaft, and thus we can get a vibration. So it is usually a good idea to, again, to find the root cause of why that drive shaft failed. I brought up the truck that was lifted. It failed because it was lifted too high and it wasn't the transfer case wasn't indexed. If you have a failed drive shaft or a drive shaft vibration, double check the motor mounts because you can replace the drive shaft and have it all balanced and nice, but it's still not going to cure the fact that the drive shaft is going to be operating at a poor angle due to sagging motor mounts. So we always want to double check all of those components. Checking the driveline angle can be very tricky if you don't have the proper tools. An angle finder does work where you can lock in against a known flat surface to be able to check that. And you check one angle versus the other and you subtract the two, and that's your operating angle. An angle finder that's magnetic is very helpful. Do keep in mind that a magnetic angle finder will not work on an aluminum drive shaft or a carbon fiber one, unless the carbon fiber has extremely heavy carbon content. But you can use it. If you get one, you get one with the zip tie attachments that you can actually run a zip tie around it and hold it stationary. And you can also get these in a digital form as well. Balancing the drive shaft is going to be extremely important. You will have small weights at either end that get welded in to allow for it to be balanced. Now, the balancing side of things is it's just like balancing a wheel, except for you have a giant balancer, and that's where you have to have a specialty shop for that. If you run into an issue that the drive shaft is out of balance and you can't 100% determine it, you can use hose clamps and you can phase the hose clamps at 90-degree intervals to try to determine if the drive shaft is out of balance. And you can do the on either end. It does take a little bit of time, but it does work very well. You're able to determine if the drive shaft is out of balance with that small amount of weight. Drive shaft weights aren't very heavy. They're, 1 to 2 grams, if that. Now, that hose clamp is a temporary fix, and what that tells you is that, all right, I need to go send the drive shaft out to get balance, but I do know that I was able to find that. And usually it's a good rule of thumb to mark the drive shaft or leave the hose clamp on and just let the fabricator of the drive shaft know that, hey, this is where the out of balance was, if they're going to be reusing the shaft itself. Now, servicing the components on a drive shaft, that center support bearing, the rubber inserts do fail on those, and they do tend to make a lot of noise. They tend to make kind of a strange squeaking noise, especially at slow speeds and especially cold for vehicles, but they can start to clunk as well. When we start to look at replacing U joints, the important thing to remember with these U joints is to check service information on how that U joint actually comes out. In some cases, like what we have on picture A there on the far left of the screen, it is a serviceable U joint. And we have a retaining clip, and that's a retaining clip that you'll use some blunt nose pliers to collapse down. It'll move the ring out, and you can pull that retaining clip. Now, the cup at the end of the U joint will still need to be pressed out. I have always pressed them out with a vise and a socket that's the right size. You get a socket that is bigger than the bore so that you can press a smaller socket that is the exact size of the cup, and you press it on one side of the joint, and the opposite of the joint goes into the washer, and you push that cup out, and you do the opposite side, and you usually have the joint easily serviced then. We can also have a internal clip. These are usually going to be circlips that you take out with a pocket screwdriver or a pick, and they come out from the inside of the yoke itself. And then the last one is a permanent plastic injection molding. Now, what this is there's going to be a machine channel inside of both the companion flange or the either end of the U joint yoke, and a small amount of plastic or Delrin is melted or injected at high temperature around that ring, and then once it solidifies, when it becomes cold, it locks that cap in place. Now you'll be able to remove the cap. The plastic and the Delrin is not that strong, and the hydraulic shop press will be enough to break it loose. However, you will not have a method of being able to retain those U joints in at that point. They do sell kits that the new U joint has caps that sit farther or further out or a little bit more proud than the plastic inserted ones, and you have an outside clip that goes around the outside, and because both are clipped out, it prevents it from falling out, and those are an option. When we start to get to larger vehicles, we do need special equipment and larger presses to be able to pull these caps off. Tiger tool is one that is used on over-the-road big rigs. That's the tool that is letter B that is on the right of the screen there. But a regular C-clamp works as well. You can get one that's specifically for U-joints. I personally have always defaulted to the shop vise and a set of sockets. Now, I brought up that some vehicles utilize constant velocity joints. You can have a constant velocity joint or a low friction joint as a drive shaft joint, but we tend to see constant velocity joints on transaxled vehicles or vehicles that are front wheel drive or rear wheel drive that has a fixed diff. Now, we have two different styles of constant velocity joints, but the term constant velocity means that we keep a constant velocity in all rotations of our joint. To where, if we remember to where our U joint is speeding up and slowing down at a 90-degree interval. Our constant velocity joint doesn't do that. So we have less frictional loss, there's smoother operation, and there's less kind of noise or vibration in the vehicle. Now, why they're not on all rear drive shafts is, well, they're not cost effective. So what we will have is these on transaxled vehicles. Now, these constant velocity joints, we can have a fixed repusel joint, which usually involves five to six, upwards of eight roller bearings that are large bearings that are going to be captured inside of a cage, and they will pivot and they will be able to move at great angles. We tend to see this type of joint on the steering end or on the wheel end of the axle shaft itself. So they're going to be the ones that turn left and right and turn at a greater angle. What they don't have the ability to do is they don't have the ability to plunge in and out or extend the length or decrease the length of the axle shaft itself. So that's why we'll see these at the wheel end. Now, on the transmission end or the driveline end inside, in the middle of the vehicle, we tend to have a tripoidal joint. Now, a tripoidal joint is going to have three discs with Torrington bearings on the inside of them, and they will slide in and out of a cup, and they allow for the plunging or the extension or compression of the axle shaft as it goes up and down with suspension travel. Now, these joints the tripodal joints can't operate as much of an extreme angle, but the combination of the Resba joint and the tripodal joint on the inside do allow for pretty big angles of operation. However, again, just like the drive shafts, if you have a vehicle and you lift it and or you lower it, usually if you start to go over about the 3 inch mark with these type of CV joints, they will fail, and it is not uncommon for them to fail. They tend to start by ripping the boot first. The boot that goes over the joint itself on the inner and outer joint is going to be a rubber boot, and it will hold all of the grease in place. Now, serviceable joints have a two-piece or a split CV boot. A lot of Volkswagens have these, and they're frankly junk. They're not what you want to run on any type of vehicle. I have converted many Volkswagens away from the two-piece ones to one-piece ones because of the lack of mess that comes with them. But they are out there and they are an option. But typically, the boot's going to be the first thing to fail. If the boot leaks the grease out, then the joint itself will fail itself, and they tend to click or they tend to make noise as the joint operates. They will click, especially at slow speeds, if the wheel is turned, or they will have a vibration issue at speed because of the different operation angle that they can run at. Now, maintenance for a CV joint, it's not really much. You're not going to be going in and greasing it at all. You put new grease in if you change the boot out, but there's not like a specific mileage interval that you would be changing a boot out. You're going to be checking it for wear though, and anytime the axle shaft does come out, you do check for operation and plunging of like the tripodal joint and operation and angle change of the Reposa joint. And then obviously also looking for any damage to the splines or any nicks or anything. The actual shaft itself on axle shafts is always going to be made of steel or a chromoly blend of steel because of the strength and the amount of torque that they have to go through. But that concludes our lecture on axle shafts and drive shafts. I know it was kind of a dry one. I tried to get through it a little bit quick for you, but there is, some good information that you can use out in the field. I appreciate you sticking along to the end of the lecture, and I will see you in the next one.